What's up, guys? It's Aribs here, back with another fun exercise here using OpenVPN. So here's the scenario today. We have a remote OpenVPN user who wants to tunnel in to the corporate LAN. So how do we do that? So our corporate HQ is over here. We have someone, remote, whether they're at home or in a hotel or internet cafe, and they need to get into the corporate headquarters LAN to have all the access to the services as if they were actually in the office, which of course today is even less likely due to the pandemic. So a few things to explain here. So I'm going to assume our corporate LAN has like a NAT address of like 192.168.1. Okay, and that's what all of our corporate services are running on. The OpenVPN server is going to have a public IP, which is not really public, but the point is it's just another subnet, 10.10.10. And as we see here, it also has a secondary NIC. So primary NIC, we can say will have the public IP. Secondary NIC port is going to have the internal LAN IP. So the point here is the following here. So this is why the OpenVPN client can connect. It connects to the interface here on the OpenVPN server that has a public IP. It also has an IP on the corporate LAN. It sits on the corporate LAN as well. And so here's how we'll connect to our internal services. So just to illustrate the point, obviously most corporate services are going to involve more than just having a single web server, but we only need to hit one to prove that this works. So we're going to say that the internal asset is just a LAMP server. Really, it's not really a full LAMP server we'll probably even install. We'll probably just install Apache and just prove that we need to use the tunnel to get to it. So how do we work this out, guys? How do we actually virtualize this and make it work? Okay, I'll quickly show you here. So in VirtualBox, I have the 3 VMs that are going to represent this. Okay, so the OpenVPN client, I have virtualized here with the machine name OpenVPN client. Okay, and how do we virtualize the other side, the corporate HQ? Well, I have the OpenVPN server that matches this guy here. I have a LAMP server that matches this guy here. So that's how we're going to make it work. Essentially in VirtualBox, I think the best way is to actually use multiple NAT networks. Okay, the reason being is that NAT network allows the machines to talk to each other. It also gives internet access, and it's just the quickest way of getting it going. Obviously in real life on real machines, we really wouldn't have to worry much about this. It would just kind of already be set up for you. But like I said, to virtualize this, I think this is the most practical way to do it. So let's talk a little bit more about the networks that we have here. Okay, so I said we want 2 NAT networks. I created an additional 2 here. It's another story, but I find in VirtualBox, if you modify the existing NAT network, it just never works. So the easiest way is just to make an additional network and assign that. So yeah, this network, network 1 has a CIDR of 192.168.1. Okay, that's our corporate network. And network 2 is kind of our fake public IP. So that's 10.10.10, all right? So let's see how this actually matches up here in our configuration here. So let's break it down to the client. Okay, we said the client's going to have a public IP. So the network of the client is the NAT network 2, which is the 10.10.10, right? That's kind of our fake public network here. Okay, how about the OpenVPN server? How does this look? Okay, for the networking, we have the primary adapter, like I said, on the NAT network 2. Okay, and NAT network 1 is the other one as well. Okay, so that will give us the same functionality that we want. The LAMP server here, how does this look? Okay, it's on NAT network 1. All right, so let's actually take a look in practice here. How do the IPs look? Okay, so the server thing that we'll talk about first, as you can see here, it has the 2 NICs. So the primary interface has like the fake virtual, or sorry, fake public IP, as I'll call it, 10.10.10.5, and our secondary NIC. This is the bridge into kind of our corporate LAN here is 192.168.1.5. So let's take a look at the other machines here. So how about our VPN client? Okay, you gotta unlock it here. So our VPN client here, it has 10.10.10.7. Okay, obviously, like I say, these IPs probably would never be on the same subnet. These would normally be on the public internet and obviously have totally different subnets. One would be on this VPN client, would be like the hotel or home ISP. Actually, in theory, it might actually be something else. It might be NATed, but the actual internet IP that it goes out through is not going to be on the same subnet almost ever, right? But we can still simulate this, and that's what we're doing here. So the LAMP server, look guys, so it's on 192.168.1.6. So just to illustrate this, what we're trying to do, let's see. So can the client ping the LAMP server? Okay, ping 192.168.1.6. No, it cannot. Okay, but what can it ping? Okay, can we ping our OpenVPN server at 10.10.10.5? Yes, we can. So here's kind of our public internet connection. And even further, let's kind of solidify this. So we have the secondary NIC here on the server, and it has the same subnet. So can we talk to our LAMP server? So our LAMP server is on 1.6. So let's try and ping it from the for the OpenVPN server. Okay, so we've established now that we don't have a way of connecting to the internal services. So we can kind of prove this out that, okay, this is representative of kind of a public internet client that can connect to the OpenVPN server, but it cannot connect to the internal assets. And that's what the VPN is going to do for us. So let's go through and make that work. And really the first step probably that I think we'll do is let's just get our Apache 2 working. Okay, so do a sudo apt install Apache 2 here. Okay, we'll just install it. All right, and let's see, can we connect, or is there anything else that we have to do? So let's open up our browser here. Okay, we'll just double check so we don't make any mistake. What's the IP on this one? It's 192.168.6. 1.6. Okay, so we get to it. All right, and just to double check to prove that we're not fooling ourselves here, let's open up our OpenVPN client, and can we connect to that IP? Let's check in a second here. Okay, 192.168.1.6. No, we cannot, and now we still can't ping it. Well, let's double check again, all right? We can't ping it. So, like I said, according to our diagram now, we have to do a few things. The first thing we're going to actually do is configure our OpenVPN server, guys. So let's get to that in just a second here. So it's going to be based on my guide here on Real Tech Talk. So I'm just going to have it up here on the actual server. I think that might be a little bit easier just to work that way. So that's what I recommend to you guys, just to go to the URL here that I'll also put in the description down below. All right, guys, so I'm going to copy my own guide here. And so I did talk about the different network options. Of this one, I think what we would probably call this one is really the option number 2, where we're having our server sit on both the public and private network, right? Kind of like this diagram that I showed you, right? The server has two NICs. It has an IP on the public side, an IP on the internal corporate LAN side, right? Now, there is another way, and it's not the only way, obviously, but a lot of times some companies and some people and admins may want to actually just poke a hole through the corporate firewall. It has kind of one benefit of removing some of that complexity. The reason being is that you would not have to have the secondary NIC. Okay, you could just port forward and kind of NAT into the target internal IP without having it to have a public IP. So the pros and cons of both. We can go over that another time, or you can post your question below if you're for or against either one. But the main point is that we make it work. Okay, so let's install the OpenVPN server, guys. That's the first thing that we're going to do here on the server side. So remember, this all occurs on the VPN server. I do recommend you give it a proper name for the VM. See, I can see right up here it says OpenVPN server. So there's no confusion. It won't get maybe possibly a bit confusing after if we don't even do that before. Interesting enough, it looks like it's already installed it by default here in Mint 20. So I actually did my original guide here in Debian, but if you hadn't done that, you would need to install these other tools here. one thing that we also will need for the next step is EasyRSA. So let's just make sure EasyRSA is installed in this distribution. I don't know that it is. Okay, so it's not installed by default. So that's something you're going to want to do if you're not using Debian. Probably the same case for Ubuntu. Okay, so that's the first step. We'll let all this finish here. And so the next step is creating all these certificates for the OpenVPN server. So the standard way, the most secure way really, is for OpenVPN to use public key authentication. So there's a bunch of steps that we have to do to make it ready and get it to work here. And so we'll go through that in just a second after our EasyRSA is installed here, guys. Okay, this is done here. So just like my guide here, then we're going to type make-ca-dir and give it a name. So in my case here in this example, I called it RTT cert. It really could be called anything. It could be called, you know, I love this channel and I want to subscribe and watch it every day. We could call it whatever we want here, guys. Okay, so I'm just going to copy my own guide. So whatever you call this, though, what you're going to do is you're going to cd into this directory. And just like I show in my guide here, if you do ls, you'll see various directories here. The most important thing to us right now is the EasyRSA binary. That's right there, okay, guys? So the first thing we need to do is run this binary, the EasyRSA, and type init-pki. So it's going to get all of our stuff ready to get going here with our certificates, okay? So the first thing we probably want to do is create our Diffie Hellman exchange key. This is how we exchange our keys in a secure way. And so it's one of the first things that we want to do here, guys. So you just type /EasyRSA gen-dh, and that's how we generate our secure Diffie Hellman key. So we'll just wait for this to finish here. And after we'll go on to the next step here. Okay, great. So that's done. Our next step here is to build our certificate authority. We need to have a certificate signing authority, basically. Otherwise, how do we know if someone actually is authorized to connect to our server? Okay, so we're going to do EasyRSA build-ca. No pass is important. If you don't use no pass, like I'm showing you here in these other steps, what will probably happen, you're going to be frustrated because your OpenVPN server won't start. The reason being is that it's going to be waiting for the passphrase on these different certificates and keys, and that's why I'm doing no pass. So in theory, it does sound like it'd be better to have it, but it just breaks the actual service. Okay, so you give it a common name. I'll just keep the default right now just for testing purposes. Okay, and you can see that it created here. Right here in home mint rtt search /pki ca.crt. So great, we have our certificate authority here. That file is something we'll need not only for the server but for the clients to connect later on. Okay, now what we have to do is we still have to generate a proper certificate here, guys, and a key. Okay, so let's just do this. I'm going to copy and paste this from my own guide. So it's important to understand what this does. Okay, if you've ever generated like an SSL certificate for a website, if you've ever had to make a CSR or certificate signing request, we do have to make a request for a certificate to be signed before we can actually create the certificate. It's kind of you know, a long process for some people, but yeah, using public key authentication, it's very important to do when we're doing our encryption here. Okay, so for this one, we use EasyRSA gen-rec, right? Because we're generating the CSR signing request. We give the file name. I'm calling it rtt request.csr. It really could be called almost anything. Just be aware of what it's called because we have to sign the very same file after we're done. And again, no pass. Okay, at the end, so there's no password required to use it. Okay, wait for it to be done. Okay, and just leave it at the default here. We see that two things happened. We have a private key, which is going to be useful later on, and we have the request. Now we have to sign the request here and actually get the certificate. Okay, so let's go to the next step here. Okay, and all we're going to do is just tell it to sign, right? So I'll just paste this in here, the EasyRSA sign request. Okay, I didn't actually copy. Here, let's do it again. Copy and paste does not always work well in VirtualBox. Okay, so easy RSA, sign-rec server, and the very same CSR we created above. Okay, so if your name is different, you're going to change it to the name of the CSR you created above. Okay, and let's type yes to confirm that we want to sign it. And it creates our CRT in this directory here. Okay, and what else do we have to do? Okay, now we want to copy all of this to our Etsy OpenVPN location here, guys. So let's just do it like this. What can we do? So we have, in my example, was done in root. Here we really can just do it like this. We can really just do a cp pki dh.pem, right? pkic.crt, pki issued RTT request on the CRT, and pki private RTT request csr.key. I'm going to copy all of that to Etsy OpenVPN. Okay, so all these files I just talked about here, we're just copying all of them at once into Etsy OpenVPN. Let's just take a look in there. Okay, lsal Etsy OpenVPN. Okay, yes, they're all copied right inside there. So we're ready for the next section here, guys. So we're going to do the config on OpenVPN. Now, this is something that is interesting to me. Depending on our distro, this may work better or worse. So some people have good luck by placing their config files inside Etsy OpenVPN server. At least on Debian, I preferred not to do that, and I'll explain why more in a second. So what I'm going to do is I'm going to place all of this directly into Etsy OpenVPN. I'm going to call it server.conf. I actually could call it almost anything, but it's kind of just traditional that people will just call it server.conf. In fact, you might actually have more than one server. That's where we're going to have to actually have different names for it. So we'll talk maybe about why you may want to have that in a second. Okay, but first let's work on our certificate here, or sorry, our config file. Okay, let's first understand what all this stuff does here. The first part in our config file here that I'm going to be copying over is our port. I specified the port as 4443 just kind of randomly. In real life, guys, the reason a lot of times that people want to use OpenVPN is the fact that a lot of locations like internet cafes, hotels, even a lot of countries, you may be behind some kind of proxied network or something that's somewhat firewalled, but you may have full access to like port 80 or port 443 TCP, or maybe like port 53 UDPs. These are kind of the most common ports that are open. I don't claim that this will get around actual, active filtering, which will actually detect if this is an OpenVPN tunnel. Well, then that won't help. But traditionally, if it's not, a firewall that's trying to actually block OpenVPN, as long as it opens these ports, which they're usually open for most locations, this will fix that problem. And the other problem too, the reason that you may not want to use IPsec and other tunnels like a GRE tunnel is because a lot of times, like I said, different routers and different location will lock down these protocols, or it could be as simple, if you've seen a lot of routers like GDWRT or just a random off-the-shelf router, you actually have to enable like PPTP or L2TP, IPsec, etc. to actually allow those protocols to pass through. The traffic won't pass through unless you enable. So that's the case with a lot of kind of public internet services you might find out there. So that's why OpenVPN, I think, really shined, especially in those situations. It's also quite secure if you really use the best cipher, and we'll talk more about that later on here, guys. So we'll say protocol TCP server. Now, the reason I'm choosing TCP is because it is the most reliable. UDP, though, gives you better performance typically, right? But TCP is the most reliable. So it's kind of up to you, on what you want to use. Maybe depends on the types of services that are going to be running over the VPN. If the VPN is going to be exclusively used, to do a lot of like VoIP stuff and video conferencing, you might be a lot better off performance-wise by using UDP. Okay, if it's doing other stuff, you may want to keep TCP, and of course, you may not have a choice. Maybe you only have one port and one protocol that's actually available to some of your users. We're going to tell it to be a TLS server and use all of these certificates. We say mode server here. Okay, the next thing we have to choose is the dev mode. Okay, and I believe OpenVPN, they still recommend that we actually use ton. Okay, so ton is what's called routing mode. So it's actually full routing. and it's normally recommended by OpenVPN. Tap is actually like a full bridge. But it's normally unnecessary. The other reason I don't always use tap, depending on the situation though, typically we won't want to use tap because some clients may have trouble with it. Some devices may not support using a tap as a dev. Okay, so I find that ton is kind of the most reliable. But yeah, depending on your needs, you may want to change it. But ton is kind of the most common and recommended. We're going to specify our Diffie-Hellman and exchange key that we specified above, and that's just dh.pem. So we say dh and the file name. That's what the file name is. We have our CA, or certificate authority, and we just say CA and the name of the file, which is ca.crt. Here I specified a manual MTU. You may not need to use this. A lot of times the automatic will work. But you might find some clients do not play nicely with the automatic MTU, and you may have to set a manual MTU for certain users and kind of have multiple servers that suit different servers' needs. And then we have our key, right? So we have our private key here. We also have our certificate, right? So that's kind of like our public key that we created earlier on. So we say key and the name of the file, cert and the name of the file. Obviously, if your file names are different, you're going to change this to match. And these would be whatever you copied into etc OpenVPN earlier. Okay, this is also important now. The if config, really probably the best way is probably to say if config and the IP and then the subnet here. Or if you just do it like this, you'll find that the first IP actually becomes the IP of your VPN server, which is obviously important to have. The reason for this, guys, is because once again, I'm assuming that we're placing our OpenVPN on the corporate LAN. So if that's the case, you obviously don't want to put it on .1 or .254. I could talk more about other directives later on, but if you use like the server directive and give like the subnet, it will usually default to putting the listing IP on .1, which will probably break your default gateway, right? Since many default gateways are running on .1. If config pool is very important, as you'll probably see later on. Things will not automatically just work. We need to know which range of IPs in our corporate LAN are kind of allocated for being used for VPN users, even though it's the same LAN IP. And also in real life too, you'll probably also want to make sure that the DHCP pool, you have some excludes on this IP range. Whatever IP range that you're actually using, you're going to want to make sure that you have an exclude there, okay guys, to make sure. Okay, and then client to client is an option that allows other VPN clients to see and speak to each other. If you don't have this, you won't be able to see each other or talk to each other. So that's a security risk to your company. You may not want to have that. But if you want to have kind of the true corporate LAN experience and other users are used to connecting to each other or directly or sharing files directly, you probably want to keep this on. Okay, this other stuff here is very important. The status log here that I defined, this is going to tell us who's connected to the server, what the remote IP is, and what their OpenVPN IP is. Okay, and this log here that we have, the var log openvpn/openvpn.log, it's very important for troubleshooting. So say that your server tries to start and fails. If you don't have this log, then you really have no way of troubleshooting very easily. And finally, you want to set the verbosity to something higher like 6. If you set it very low, you won't get a lot of output. So that's why we have our config like that. So let's go back to the diagram though. So how do we want to do this? Okay, so our public IP is like 10.10.10. right? And internal IP is 192.168.1. So what we need to do is actually give out, listen on this subnet range, okay? And we need to give out IPs in this range. Okay, so why don't we just copy this example here and modify it for our needs. Okay, I'm just using VI here, and we're just going to do some inserting here. Okay, so what did I say we had to modify, guys? We need to change this for our situation. So our situation that I said here is that the corporate LAN, the IP we want this guy to listen on, is the following here. Or so we want our public IP. This is going to listen on our public IP here. Okay, so why don't we say 10.10.10.85 and something like this, all right? And how about our if config pool? Well, this has got to change because I said our corporate LAN is the 192.168, right? So let's just change this. Okay, let's change this to 192.168.1, and once again, maybe kind of similar. Let's keep it at .90 and make it end at .100. Okay, so we'll save that. And so that's our config file. What else do we have to do? Okay, it's important that you understand how the service is supposed to start. Okay, so let's take a look at this. So normally you would expect that I would just do like a systemctl start OpenVPN, but that's not going to start your server. That's going to start kind of like the shell service for OpenVPN. It's not going to start your actual server.conf. So what you need to do is do the @server. So if you guys see here, I call it server.conf. So you want to obviously have the same convention here. If I called it areeb.conf or realtechtalk.conf, then I would want to change that to the name. So I would change my to whatever the config file was called. Obviously, you don't include the .conf. So let's give it a shot here, guys, and see what happens. Systemctl start OpenVPN @server. Okay, and let's go check our log now. Do we have any log output? So how about our status log? Okay, we need to do sudo for this. Okay, so we can clearly see that no one's connected here. Otherwise, we'd see some information, some fields here, like their common name, real address, etc. Right now, we don't see that. So no one's connected to our server now. Let's see the server log, though. Okay, so how about the OpenVPN.log? Okay, you need sudo on this again. Okay, and this is what we'd like to see. We want to see here, guys, that it initialized correctly. Let's also take a look here at how do our IPs look here. Okay, so we're listing on 10.10.10.85. Okay, why is that? Let's compare that to our config here, guys. Okay, go down here, and if you guys look, this is what I specified, right? That's why ton0 is this address. So this is what the OpenVPN is going to be listening on, guys, okay? Okay, and also we have our ifconfig pool, which are going to come into play later on. Let's check something out here. Let's see how this works. Okay, let's go back to our client now, and let's just see if our client would possibly have access to this VPN server. Now we know that it's not fully ready, but why don't we ping 10.10.10.85? Okay, good. Okay, so in theory, we believe we should be able to connect to the OpenVPN server. If we want to take it even farther, why don't we do a telnet just for troubleshooting, okay? And remember, the port that I had it listing on is 4443. Okay, so yeah, it's there. We're connected to it, so good. We think we're on the right track, but we're not done just yet, okay? So let's finish off this this fun stuff here. On the server side, if you actually need to run this sed command, really all I'm doing, guys, is I'm just enabling this. Maybe I should actually just show you manually in sysctl.conf, okay? So let's just quickly add this here. Okay, and let's just search for IP forward. Okay, so all that sed command is it's really just doing this. It's just uncommenting that. Just a kind of a quick hack, but I want to show you how it's manually working. We also have to still type the sysctl-p. This is actually going to apply that change. And basically what this does is allows the packets to be forwarded in and out from the VPN server. If we don't have that, things will not work, and you can find that out for yourself if you want to change it back later. But trust me, you do need this in order for it to work. We're going to do a cat proc on the IP forward entry here in procsysnet IPv4. And we want to see that it's a 1. If it were a 0, it means that you did something wrong, that it's not enabled, and it's not going to work for you. So make sure that we actually did it right, and that is working. So something else that's going to be a little tricky to remember, as I say here, guys, is routing, okay? So the reason for that is the following, and actually really should go back to the config file. But so in our config file, we have a push, and actually that's one thing we actually have to still talk about and change here, guys. So actually, there's one thing that I didn't go through before. It's our push route, okay? So the push, guys, is something that the client gets, okay? So we could push DHCP, we could push DNS, and that's normally what you'd want to do. But in this really simplistic example here, we're just going to do enough just to get it working for now. So we're going to push the 192.168.1.0 route, okay, guys? Because that's the IP range that the client gets. We want to let the client side know that to route into our 192.168.1 network, that it all has to go over the ton 0, all over the VPN connection that it establishes with our server. So whatever, basically your if config pool range is, that you want to specify a push route so the client knows how to talk to it. So the client knows how to talk to the OpenVPN server, which is good and important. Actually, to actually apply that change, we should actually restart the OpenVPN server. Okay, so restart it. But here we also need to add a route back. Okay, so why don't I do the .90, because that's gonna be your first client IP. Normally we can talk about how to make some upscripts and other stuff like that when it connects, but I think it's important to understand how it manually works. So we're gonna do a route here. Add 192.168.1.90 dev ton 0. Okay. And what this does is it tells our OpenVPN server and really the rest of the network, because now the OpenVPN server kind of becomes the router, the gateway for the LAN computers about how they communicate back and talk to clients that have a tunnel IP. That's why we want to actually designate these tunnel IPs. So you basically essentially want a route add for each IP. So I may actually want to do something that would route it to like 91 to 100. But for this example, just understand that each IP has to be added that way as a route. Okay, and that pretty much catches it. You may also want to make sure though that that the rest of the LAN is still routing where it should. You can do a route-n to check on this. Okay, so this looks fine to me. It goes over EMP0S8 with the only exception here though, guys, of ton 0 being a bit different, okay? Which is fine, because we just manually define that. That's what we want to see. Okay, and let's generate a client key. So we still have to do our client key here. Let's just copy and paste this. And so what I recommend for this is that we actually do something that is sensible here. So we have to make sure that we are keeping track of what we're doing. So now for testing it's fine. In real life though, just imagine this: if someone gets fired from the company or they leave the company, you want to have keys that make sense. So what I would probably do, I'd probably name this key like first name dot last name at domain or something like that, so you know which key belongs to who, so you can revoke access to the VPN server. Now, if you don't do this and someone is removed from the company, you have no way of stopping them or knowing which certificates to revoke to stop them from connecting back to the corporate network. Obviously, that would not be something you want to explain to your boss, right, guys? So yeah, just something for real life here. So make sure you keep track of that so we don't have that problem. It wouldn't be a pleasant thing to explain. All right, so let's build this this client key just by running this easy-rsa build-client full, and it gives us the keys that we want the client to have. Okay. So now from here, we're almost done actually, guys. Now we need to connect the client. Before the client connect, actually though, it actually needs all the correct keys. So it's a little bit insecure, but just for testing purposes, I'm going to tell you guys just to SCP this to your client side. So double check what's your client side. Okay, we're going to go here and just double check our IP so we know we're talking to the right IP here. And we see here that we have a .6 here, guys, okay? 10.10.6. So why don't we do an SCP-R for recursive, which is going to copy the entire contents of RTT certs to mint at 10.10.10.6. Okay, and we'll put the colon there to put it in the home directory. Okay, so we'll connect for the first time. Obviously, for this to work, you have to have SSH running on the other side of the other target. If you don't, you'll have to take care of that before. So let's talk about how we arrange all of this, guys. Okay, now I think the easiest way for testing is actually to use this command here. Now I can show you later on how you use the GUI in like Mint or Ubuntu. But for now, let's just do this. Basically in real life, you'll actually want to use an OpenVPN, like a file.ovpn, which is going to be like an OpenVPN config file. And pretty much, we're just making the config file on the fly by typing it this way. Okay, so we're going to type the following here, and we'll run it as sudo. Okay, otherwise you won't have permission to create the ton adapter. We're going to do --poll. Okay, so we need the -- poll. If you don't have poll, it will not pull an IP from the remote side. It will not pull what we pushed, so it won't pull the route that we pushed out. Okay, and it's a TLS client. The reason being is because we have a TLS server, right? So everything kind of has to match the server side. We have a dev ton because our server was a ton, right? And then as well, we have the key here. So the key is an RTT cert, right? Under PKI, private, and realtechtalk.com .key. Okay, so we need that one. That's the one that we generated. And then we also need this cert, okay? -- cert. And RTT certs, PKI, issued, realtechtalk, and .crt. And then the next option is our CA, right? This is the CA that we created on the other side, PKI, CA.crt, and then -- remote, and we got to go double check that we have the correct IP on the remote end here. Okay, just do an IPA, always double check. So what is our 10 address? So it's going to be 10.10.10.85, okay? So 10.10.10.85. One more thing is also the port, okay? And one other thing, now this depend is kind of interesting. I've had about half the time on Debian, I never had to type this, okay? But let's be very specific. We should specify the protocol. So we're going to say proto TCP client because we're using TCP. Now on some version of OpenVPN, it seems to default to trying UDP. Obviously that would break and you'd be very frustrated wondering why it doesn't work. So don't do that. But let's see guys, can we connect? What happens now? Okay, so it looks good. It says that we've initialized our connection. Everything looks good. Let's see about the route here on the client side, guys, okay? So for the route, we have the 192.168.1 that I told it to push, right? It's going over ton 0. It doesn't happen by itself. It happened because of that push that we gave in our server config file, okay? So this is the interesting thing here now. Can we still ping our tunnel IP? Yeah, we can still ping it. That's where all the traffic is transiting through. And I said this is the IP of the LAMP. And just to prove that I'm not tricking you guys, so you can see I'm on the OpenVPN here as a client, right? You can see my IPA, and you can see I have this, right? This is the same subnet as our LAN, right? Over my ton 0. So let's disconnect this now. Okay, actually let's show you one more time. Look, so yeah, we are able to connect to this guy, right? Over the corporate LAN. And what happens when I disconnect the VPN? Can I still do it? Right, we're off the VPN at this point, right? I just closed it out here. Okay, and we can no longer connect, and let's see. Let's connect once again. And does it work? Okay, we're back on the VPN. Let's try again, and it works. So we proved it out here. What's one other way we can break this, or where it actually needs to have a bit of tweaking here? There is one parameter here. It's the proxy ARP that we need to set up here. Okay, so we can check all these ones. Basically, the easiest way is to enable proxy ARP on everything, at least in like Ubuntu and Mint, and really probably a lot of Linux distributions. If you don't enable proxy ARP, it will not transfer the ARP address of the MAC address of our client. It's always kind of cool to see this stuff in action, right? So we have secure access, or OpenVPN, corporate network. Obviously, there's a lot more things we can do. I'll probably have to make some more videos to show you how to revoke keys and how to secure and kind of tighten this up, how we automate this whole solution. So if this is something that you need help with, if your company is trying to work on this, and that's stuff that I've done and my company's done for quite some time, guys. But I hope that this does help. Hopefully it gives you a good starting point for your company to offer new options to your remote users. Definitely from what I've heard, it's become more and more of an issue, right? Another thing we could talk about in another video is probably the best VPN performance. And how you kind of get more throughput, because I'm hearing more and more that the average kind of enterprise grade router or firewall is just not cutting it for enterprises which have a lot of bandwidth usage just from their massive amount of VPN users. So anyway, that's another interesting video that I hope we can do later on. Anyway, guys, thank you for watching. Please like, share, and subscribe, and I will see you guys next time.